7.6, Strategies for Integration. So what's the point of this section? Well, we've been learning lots of different integration techniques. We've learned how to integrate by substitution. We've learned integration by parts. We've learned special methods to deal with integrals with trig functions in them. We've learned how to do trigonometric substitutions. We've learned partial fractions. So that's 5 different techniques or so that we've learned. And so the point of this section is kind of review all of those topics and also help you understand how to choose techniques. So in real life and also and not so real life on exams and stuff like that, I might not say, evaluate this integral with this integration technique. It might be incumbent on you to figure out, here's a given integral, what technique works best. And so that's what we're going to be looking at in this section. So we're going to be reviewing all of our different integration techniques and tips and tricks, and then also a couple new things to think about. And we'll be discussing how can you look at an integral and be able to say, this is what I should try first. So our first point to make here actually isn't so much anything that we've talked about so far, but it's worth emphasizing this as something to think about. It's the idea of simplification. So something to think about is there ever a chance to rewrite your integrand in some way that makes it easier to integrate? So when we see x cubed minus 1 over x minus 1, your mind might jump to partial fractions. Your mind might jump to substitution. But really, the best way to tackle this is, x cubed minus 1, that can be factored as x minus 1 times x squared plus x plus 1. And so if we rewrite this integral, we can see pretty easily that our factors of x minus 1 are going to cancel. And so we are just left with the integral of x squared plus x plus 1, which of course is x cubed over 3 plus x squared over 2 plus x plus our constant. So we shouldn't do any of our fancier techniques. We should just say, hey, we can simplify the integrand to make our life a lot easier. Now, ditto in the second one. So we've got, it's a rational function, but we don't want to be thinking substitution or partial fractions. We want to break this up into two separate fractions. X divided by square root x. X divided by square root x is square root x. X cubed divided by square root x is x to the 5/2. And this integral, the x to the 1/2, becomes x to the 3/2 divided by 3/2, minus x to the 5/2 goes to x to the 7/2 divided by 7/2, multiplied by 2/7, and that's that answer. A simplification of a different form, 1 over sine squared x, the antiderivative of that. So, that might, your mind might jump to section 7.2, how to handle it. You might say, oh, maybe we should apply a double angle identity to it, rewrite sine squared x as 2 sine x cosine x. Maybe you think, oh, we should replace it 1 minus cosine squared x. But actually, there's a different simplification. It actually requires less writing here, which is 1 over sine of x is cosecant x. So really, what is this right here? This is the integral of cosecant squared x dx. And one of the formulas you should just know off the top of your head is that the antiderivative of cosecant squared is negative cotangent x plus our constant. So knowing that the derivative of cotangent x is negative cosecant x squared x gives you this formula. You can always quickly rederive it if you forget that. So that's our first lesson here for strategies for integration. Think about how to simplify what you're writing.